Hello, and thank you for joining me for my presentation on preparing for blockchain in a new era of smarter food safety. Hi, I'm Kathy Barbeire, Marketing Manager for Cat Squared. So I decided to open this presentation with the Dilbert cartoon because it's relevant and it tickled me. So the IT manager says, this would be a perfect application for blockchain. And the marketing guy asks, can you explain that in terms that I can understand? And she says, I kind of doubt it. And he replies, because you're a bad explainer, right? So for anyone who didn't get it, there are a couple jokes there. One, engineers and IT people don't speak English. And two, even if they did, the marketing guy would be too dumb to get it anyway. So I hoped that by poking fun at myself for being the marketing chick, we could ease into a topic that can be a little intimidating. When I first started writing about blockchain a few years ago, there really wasn't a lot of great industry related content available. And that's changed a lot, especially over the last year as manufacturers have had to deal with all the fallout from the pandemic. There's now a sense of urgency around Industry 4.0 technologies to automate the plant floor and to strengthen the food supply chain. So, depending on our audience mix, several of you may already be familiar with smart contracts, consensus algorithms, and the differences between permissioned and permissionless platforms. But for those of you who are still new to blockchain or feel intimidated by Industry 4.0 technologies, fear not. If the marketing chick can understand blockchain, you too can understand blockchain. So as I mentioned, I am the marketing manager for Cat Squared. I have been here for a little over 6 years now. I have a degree in technical writing. I minored in IT, and I went back to UALR to complete the MBA program. Prior to joining Cat Squared, I spent most of my career in the nonprofit sector. I mainly worked with issues related to poverty, hunger, and homelessness. Um, at first, it was honestly a little intimidating to shift my career from charity work to manufacturing technology. But the common thread that connects my nonprofit work and my for profit work is the role that I've played in using data and technology to tell stories and build trust amongst stakeholders. So, in manufacturing and supply chain management, you talk about KPIs and critical data elements. In the nonprofit realm, we talked about impact measurements. So, as a program manager at a homeless shelter, I measured how many individuals left with a job or accumulated savings or attained a GED or work certification while in our program. And those were the KPIs we used to measure how effective we were at fulfilling our mission. In food manufacturing, you're measuring how effectively and efficiently you bring a safe quality product to market at a profitable price point. But how do you prove that that product is safe? That the cold chain wasn't broken anywhere along the supply chain as your product journeyed from the plant to the retailer? How do you prove that your organic product is really organic? And that's part of what really excites me about blockchain is its ability to use immutable data to tell your brand story and build trust with consumers and other supply chain partners. So some members of the audience may remember a few years back when Governor Asa Hutchinson launched blockchain for Arkansas. I remember there were representatives from Walmart, Tyson, JB Hunt, and other Arkansas companies there. So, as part of my role with Cat Squared, I've been representing our company on a blockchain learning group that grew out of blockchain for Arkansas. And these collaborations led to the passing of HB 1944, recognizing electronic signatures in blockchain enabled smart contracts in Arkansas law. So I got to be a small part of blockchain history, which was pretty cool. So for anyone who's not familiar with Cat Squared, we develop smart factory solutions that automate the plant floor and support continuous improvement efforts for food manufacturers. So our system collects data from all plant floor activities and can integrate that data back into a company's ERP system or display that data in real time in plant floor scoreboards or executive dashboards. And this gives our customers a full view of all production and inventory movements in real time. And in 2019, Cat Squared became the first MES provider in the food industry to become an onboarding partner with IBM Food Trust. And this partnership will expand the reach of our current system to not only deliver full visibility of product movements from within a plant, but will soon be capable of delivering to our customers full visibility of ingredient and product movements across their supply chain. So, as I mentioned, when I first started writing about blockchain, there wasn't a lot of content available in the industry. And I noticed that there were a lot of gaps in people's understanding about what the technology was and how it works. So my original goal for this presentation was to provide that foundation of understanding and then move into how that technology is being applied into the industry. So we'll start this presentation with an overview of what blockchain is, how it works, and who the key players are in the current landscape. And then we'll move into practical applications. What's the business case for blockchain? What forces are driving adoption and what barriers are preventing adoption? And then we'll end with some specific steps that manufacturers and other supply chain participants can take to prepare for what the FDA has dubbed a new era of smarter food safety. So first, what is blockchain? Blockchain is a form of distributed ledger technology, which means that it's a shared ledger stored across multiple locations. To illustrate how blockchain is different from the current use of EDI or electronic data interchange, let's examine how participants in the supply chain currently interact. So as you can see in the top graphic, EDI messages are point-to-point one-way communications. Each party has unique and limited visibility, and therefore each party has their own version of the truth. The lower graphic shows how supply chain participants can contribute EPSIS data to a blockchain. Because the ledger is shared, data is transparent to all permissioned participants within the blockchain. And since the ledger is a type of database that only allows entries to be appended rather than changed or deleted, the data on the ledger is immutable, which means it's unchangeable. And because it's stored in multiple locations, no one supply chain participant can modify the ledger without everyone knowing. And this creates trust in the provenance of the ledger, what blockchain providers call security through transparency or trust through transparency. So there are multiple blockchain platforms. The two largest next to Bitcoin are Hyperledger and Ethereum. And there are several differences between these two platforms, but the main differences that you'll be most concerned with are related to data integrity, processing speed, and confidentiality. So before I discuss data integrity, let me first explain a little bit about the mechanisms used to build consensus and why this is important. So as I mentioned earlier, blockchain is a distributed ledger stored across multiple locations. So each participant owns a full copy of the ledger, meaning there are multiple copies of the ledger stored across the blockchain network. The graphic on the slide illustrates the differences between a traditional centralized database network that most of us are accustomed to on the left and a distributed network illustrated on the right. And as each participant on the blockchain network writes an entry to the ledger, all participants constantly have to agree on the true state of the ledger. And this process is called reaching consensus. And this is what prevents double spending. So what is double spending? As many of you know, blockchain is the technology that makes cryptocurrencies like Bitcoin viable. So when you're sharing files on the internet, it's possible to make endless copies and send them to multiple recipients instantly. However, if I want to send $1 to someone, I can't also be capable of sending that same dollar to someone else. And previous forms of cryptocurrencies failed because malicious participants found ways to double spend currency by injecting faulty transactions onto the ledger. So Ethereum solves this problem by using the proof of work algorithm. Now, this is an intensely complex algorithm that requires a significant amount of computing resources to solve. So once a participating node, called a miner, solves the algorithm, they're rewarded with Ether, which is Ethereum's built-in cryptocurrency. And their copy of the ledger is then sent across the network, and their solution of the algorithm is verified by other nodes, and that version of the ledger becomes accepted as the truth. And all transactions on that are stored on that ledger become an immutable block of data on the blockchain. Hyperledger uses something called practical Byzantine fault tolerance to solve the double spend problem. This is a different type of algorithm that requires 2/3 of all nodes, or what they call validation peers, to calculate the same hash code. And I realize all this is a little overly technical, but what's really important for you to understand is that this type of validation uses significantly less energy than proof of work, which translates into more transactions per second. So Ethereum can handle upwards around 20 to 30 transactions per second, whereas Hyperledger achieves an end-to-end throughput of about 3,500 transactions per second. Supporters of the Ethereum platform claim that the proof of work algorithm delivers a higher degree of data integrity than practical Byzantine fault tolerance. However, Hyperledger is a private permissioned platform, which means that only verified participants can view data, and only participants with special rights can verify the transactions on that platform. So users don't face the same level of risk from malicious actors that they would on a public permissionless network. So the bottom line is that Hyperledger has become the preferred platform for B2B transactions because of its speed, scalability, and also its ability to allow for confidential transactions, which is important for suppliers participating in blockchain projects that include competitors as a part of their supply chain. So currently there are several food-related blockchain projects in different stages of development. The biggest solutions currently available are IBM's Food Trust, which is designed to meet the needs of grocery retailers and distributors, and Ripe.io's agricultural blockchain, which focuses on freshness during distribution. And both of these solutions run on Hyperledger. Covantis was launched in March of 2020 to develop a blockchain-based prototype for international bulk agricultural commodity trading. The initiative selected Consensus, which is an Ethereum technology company, to develop its platform. So you'll remember from the table on the previous slide that Ethereum was listed as a permissionless network, which is one of the reasons why Hyperledger has been considered the blockchain of choice for business. So this is an excellent opportunity to point out how the blockchain ecosystem is constantly evolving. So as you might have gathered from the previous slide, it takes a lot of electricity to power a blockchain due to the energy required to process the algorithms. So blockchain developers are constantly working on ways to decrease energy use and increase processing speed without sacrificing security and data integrity. For Covantis, Consensus is building a secured platform on Quorum, which is a permissioned fork of Ethereum and was originally developed by JP Morgan Chase. So outside of being a big buzzword, what is the real business case for blockchain outside of the financial services sector? The food industry probably really started paying attention to blockchain technology when Walmart mandated their leafy green suppliers to implement end-to-end traceability back to farm. And to help their suppliers meet this goal, Walmart's letter mandating that change referred suppliers to the IBM Food Trust Network, which is a blockchain solution pioneered by IBM to improve food safety. So obviously, Walmart sees the value in blockchain's ability to limit the scope and scale of recalls. For example, in the case of the E. coli outbreaks linked to romaine lettuce, retailers knew that the source of the outbreak was lettuce from the Yuma growing region. Unfortunately, they had no way to easily identify which of their lots were sourced from that region, and as a result, the only solution was to pull all lettuce from stores around the country and at significant cost. If all participants along the supply chain had been contributing data to a blockchain, a specific product lot could have been located anywhere along the supply chain instantly, which would have dramatically limited the cost of the recall. But the true business value in blockchain is realized through the removal of friction through transaction processes, increased efficiency in transactions, and quick dispute resolution. So, using smart contracts, the SLAs of a business agreement are turned into code that lives on the blockchain, automating payments and resolving simple disputes. The way this works is just like in a traditional contract, the terms of the smart contract are agreed to by all parties. And once the contract is finalized, the terms are turned into code that lives on the blockchain and cannot be changed without all parties knowing. So during our learning groups, there was a representative from IBM who said that about 40% of the time spent on their blockchain projects were spent getting all participants to the table to agree on the rules of governance of the blockchain. And so, what early adopters are realizing is that they need to include an expert in dispute resolution as part of their project team to help lay the foundation of the agreements upon which the blockchain smart contracts will be built. So, if you're considering a blockchain project, you should be aware that a significant chunk of time is going to be spent on this first step because writing code is easy, building relationships is hard. Now, once the terms of the contract are finalized and turned into code on the blockchain, a triggering event occurs. This could be a shipment of product is sent and received, or a lot passes inspection, or whatever event is defined in the smart contract. That event triggers the execution of the contract based on the pre-agreed upon terms. And at this point, a settlement process occurs, like an automatic payment is sent or an invoice is generated. And this is when participants along this supply chain start reaping the benefits of all the work they put in, nailing down the details of the smart contract. Because they worked out ahead of time what would happen with any foreseeable contingency, like a shipment arrives damaged, or not enough product was shipped, or too much product was shipped, or whatever the issue may be, the data is logged, sent up to the blockchain where it's visible and verifiable by all participants who are permitted to view the data. And this event executes the appropriate clause within the smart contract, and the settlement process occurs automatically based on that agreement. So by streamlining transaction processes this way, you remove a lot of time wasted disputing the terms of your agreements. And in the food industry, especially in the meat industry, time is valuable when you're dealing with perishable products being shipped or live animals under stress during transport. The more time you can shave out of your transaction processes, the more you'll be able to reduce loss due to DOAs and spoilage. And blockchain can create additional value at the enterprise level. As all plants across an enterprise begin contributing data to a blockchain, managers can do performance comparisons by plant or by product, leading to new levels of insight. For example, data analysis could reveal that there is consistently a problem at plant X on Tuesdays, or there are always long dwell times at plant Y for product B. So insights like these could lead to improved efficiency across the enterprise by identifying opportunities for process improvements and developing incentives for employees to improve performance. So beyond the business case, where is the industry seeing pressure to adopt digital technology? So obviously in 2020, the COVID pandemic's disruption of our global supply chain is driving our whole industry to look at ways to automate wherever possible. Industry 4.0 technologies like blockchain have proven to remove paper, people, and time from processes. So here I want to take a few minutes and look at the current landscape and discuss what's going on with government, retailers, and consumers. So, on the global front, in January 2020, the Global Forum for Food and Agriculture proposed to establish the International Platform for Digital Food and Agriculture. Key objectives include establishing harmonized policy frameworks and best practices for technology adoption for food value chains. In the US, both the USDA and FDA have put forth proposals that point to a more digitized supply chain. In the August 5th Federal Register, the USDA's Agricultural Marketing Service proposed amending its rules to include using distributed ledger technology to trace the supply chain of organic products. In July, the FDA released its blueprint for a new era of smarter food safety, a campaign intended to strengthen the FDA's protection of the food supply chain. And the core elements of the blueprint include supporting tech-enabled traceability, adopting smarter tools and approaches for prevention and outbreak response, developing strategies to ensure consumer safety as new models evolve and retailers modernize, and nurturing a food safety culture throughout the food system. Now, I want to point out that none of these bodies are mandating industries adopt blockchain specifically. There are many traceability solutions available using a combination of cloud hosted databases, EDI, and various IoT technologies. And many of the business cases that I mentioned can be achieved without blockchain, with the exception of using smart contracts to streamline transaction processes. So that's still a pretty strong use case. Prior to the pandemic, the main source of pressure in the industry to adopt blockchain was coming from large retail customers like Walmart, as well as the perceived consumer demand to know where our food is coming from. So the last in-person conference I attended was the National Conference for Food and Agribusiness at Purdue University. And there were a couple points made at the conference that I wanted to highlight during this presentation that related specifically to how retailers are pushing the industry to respond to consumer needs. So first, consumers have many misconceptions about how their food is grown. When asked on a survey whether broilers are given growth hormones, only 8% of survey participants answered the question correctly. And I bet that 8% were probably members of the food industry. So our population is becoming increasingly urban, but consumers still want to feel connected to their food. And today's technology gives us the expectation that all data should be available at our fingertips. So, how can food manufacturers harness this technology to educate and build trust with consumers? Another point that was brought up was because retailers are closest to consumers in the supply chain, they are most responsive to consumer needs, and they are the ones pushing changes in the industry. And this was a key point that really struck me. Additionally, retailers are increasingly willing to go around manufacturers to create the products they need if they can't get the relationship they want with the manufacturer. And therefore, in this environment, manufacturers who understand and respond to consumer needs will win. So one of the most exciting benefits of blockchain for the food industry is its ability to allow manufacturers to connect directly with consumers. So here I'm using a demo version of Cat Squared's consumer traceability portal to illustrate how blockchain can help manufacturers build brand affinity. By sharing their stories with consumers about what goes into making a safe, quality product, brands can build consumer loyalty. So by scanning a QR code, let's see if I can get this to work. Great, it's slowly loading. So by scanning a QR code with a mobile device, consumers can access data about your supplier's certifications and determine whether or not your product was ethically sourced. And let me see if I can get this one to pull up. They can also find out if the product in their refrigerator is subject to an active recall, and they can learn more about that recall. And I'm trying to get this last one to load. Or you can also include live streaming video from the farm or any other kind of marketing related content that you want. In fact, when I was at the conference in Purdue, there was a grower who was installing webcams at his facility to have a live stream of his growing operation. So that's a real thing that's currently happening. So blockchain is creating new opportunities to differentiate between bulk commodities and premium products through value-added data. So what are some of the barriers blocking blockchain adoption? The main barriers are apprehension and lack of understanding of the technology, lack of data consistency and common definitions across the supply chain, and the continued use of antiquated data collection processes in pockets of the industry. So I know our team still walks into plants and sees lots of paper and spreadsheets. And here I am talking about blockchain, and there are places that aren't using EDI yet. So that there's a lot of room for improvement in pockets of the industry. So what are some practical steps manufacturers and suppliers can take to address these barriers? First, understand your processes. Developing a process map gives manufacturers a visual understanding of processes occurring on the plant floor, what data is being measured during those processes, and how that data is flowing across their network. So using this process map as an example, the bottom layer represents a physical process occurring on the plant in the plant's receiving area. The second layer identifies hardware used to take a measurement or control the process. And in this case, a truck drives over a scale to capture the gross weight. The third layer represents the data layer, or how the data is being recorded. This could be paper and spreadsheets, or this could be an MES system. In this example, this is where our system would pull the receiving schedule from the ERP to check in the truck, receive the captured weight, and assign a queue number for pre-unload inspection. The data collected from the inspection would be communicated back up to the ERP in the next step of the process, which isn't illustrated on this map. But having a clear understanding of what data you're collecting and how it flows across your network helps you to identify operational value drivers and develop measurable KPIs for data-driven decision-making. And it's also critical for the next step. Adopting common language and common standards. So in order for blockchain and other digital technologies to be interoperable, common data standards must be adopted across the value chain. The most widely used is GS1, which is used to identify, track, and trace critical tracking events and key data elements. So EPSIS, which stands for Electronic Product Code Information Services, is a global GS1 standard for creating and sharing visibility event data, both within and across enterprises. And there are 6 standard EPSIS event types that represent real-world events. Commission is an event signifying the creation of an object, like the birth of chicks, for example. Transformation is an event signifying an irreversible transformation of an object, like slaughtering chickens into carcasses. That's an irreversible event, obviously. Aggregation is the grouping of objects into a batch, and disaggregation is the ungrouping of objects into smaller individual objects. An observation is an event signifying an observation such as quality testing, and decommission signifies the deletion of an object from the supply chain. For example, carcasses that do not pass a quality test are discarded, and this event can be represented as a decommissioning. And for each event type, there are 4 dimensions recorded: when, what, where, and why. And here you can see an example of a transformation event where 2 inputs are creating a new output. In this case, 100 bushels of onions and 50 crates are coming together to create 50 bins of onions. And each input, the onions and the crates, have their own G10s and their own lot ID numbers, and they create a new product lot with a new G10 and lot ID. So this is both a transformation event and a commissioning event because we've created a new object, the batch of 50 crates of onions. If this were a more complex product, like a batch of chicken nuggets, then you'd have more inputs like chicken, batter, oil, packing materials, etc. Each of those items would have its own lot number in G10, and each would be connected to the new G10 and lot ID at this plant identified by its GLN or its global location number. So when you start seeing how standardized data can easily flow across a network, you can imagine how easy it could be to perform a forward or backward recall in the matter of seconds. The next way we can address barriers to technology adoption is by building a culture of knowledge sharing, both inside your organization and outside your organization with your supply chain partners. Regularly meet with your plant leadership to establish standards and share best practices and hold each other accountable. Likewise, meet with your trade partners, discuss your technology platforms, see where you can standardize your data collection processes, and look for opportunities to integrate your traceability data and streamline your transaction processes. This will improve efficiency and traceability across the supply chain. And also remember what I said earlier, writing code is easy, building relationships is hard. So it's important to develop strategies to bring value to all supply chain participants. The very nature of this new technology requires collaborative thinking. A blockchain is only as strong as its weakest link. If a supply chain partner doesn't see the value in adding an additional cost or an additional step to their process, then they're not going to participate. And finally, develop approaches to educate consumers about how food gets to their table and how to handle and prepare it safely. Take your time to build trust. Let consumers know you care about their concerns for safety, sustainability, and humane treatment. And show them the data to back up your claims. Because as I mentioned earlier, in this environment, suppliers who are most responsive to consumer needs will win. I hope you were able to receive some value from today's presentation. If you have any questions, you're welcome to email me at kathy.barbeire@catsquared.com. You can also subscribe to our monthly newsletter on our website at catsquared.com. And feel free to register for our user summit this August. It'll be August 16th through the 20th at the Winthrop Rockefeller Institute atop Petit Jean Mountain. And this year's focus is going to be all things Industry 4.0. I hope to see you there, and thank you again for joining me.